Morning, boys and girls. As we all know, if you've got tractors and all the other sort of vehicles, you get starter issues. So you see here, got the starter and the solenoid, and I keep getting intermittent clicking noises. That click wouldn't turn over. So now today we're going to show you how to test it, see what the problem is. Well, I've been suffering from the dreaded clicking noise, was obviously the solenoid pulling in. The solenoid's pulling in, click, 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 but the starter motor isn't turning. And that's slowly getting worse. I don't do it all the time, but it's intermittent. So that's on the borderline of working and not working. But one of these days, late at night, I'll be trying to start up the tractor on the beach. And it ain't the start, is it? So I'm now going to show you how to electrically test these so we can try and fault find what the issue is. Well, first thing you need is electrical test meter. This is a fluke meter. It's quite old, but it still do the job and that work a treat. Fluke are very good meters, but really I got a $9.99 cheapie, but I keep in the boot all the time, and that worked just as fine. But this is for working on high voltage as well. You won't be using them cheap nasty ones for working on 400 volts, would you? But even if you've got a cheapie, for working on 12 volts, that's good enough. If we look at this solenoid, we'll notice it's got 4 terminals on it. That's got 2 little terminals. One is plus 12 volts when you turn the ignition on, and the other one is plus 12 volts when you start. And also you got your big terminals, what your main power terminals, what can handle the current to turn the starter motor. So basically the little wires pull in a little coil, what pull the solenoid in, and the big wires, that's a switch across there to turn on to allow the current to flow through the starter motor. Well, the most important thing to do when you're working on vehicles, any vehicles, especially these old ones, is you want a good earth, because all your testing for voltages will be down to earth. So you need a good earth to start with. I'll put it on resistance, touch the terminals together. That's 3 ohms. So that 3 ohms is the internal resistance of the meter and the leads. So I'll get the crocodile and I'll go on volt on the starter. Give it a wiggle. And then that is part of the body. So I should give it a wiggle there. I'm getting 3.3 ohms. So the resistance between there and there is 0.3 ohms. Well, that's good enough. I'm happy with that. So that's when you need to start. Well, what I need to do now is I don't know which switch, 12 volts when you turn the ignition on, or 12 volts when you try and start it. So what I'll do now is I'll go and turn the ignition switch, and we'll see which one get 12 volts. Well, I'll just turn the ignition switch on, and obviously we want to be measuring DC. So obviously volts DC and volts DC there. So we'll stick the lead on the bottom one first, 12.4 volts virtually, and the top one is 0 volts. So we know that bottom one is 12 volts permanent when the ignition switch is on. So that must make the top one 12 volts when you start. And the easiest way for me to check we've got 12 volts when we start is turn the key. So that's what I'll now do. Got to just put my foot on the clutch because it won't do anything without it. And typical in true testing fashion, that always work. I turned it over, that done exactly what it should have done. Start, or tried to start. So at the minute, the fault isn't there, but I gather that'll be a resistance. That'll either be a resistance across the switch, or resistance between the terminals on the switch to the starter or down to earth. So we'll now go down that route. So we know us turning over, that's just going to be now a resistance thing, poor terminals, that sort of thing. So with that on 12 volts DC, I'll put this on the power terminal. Give it a good wiggle. And I'm not getting nothing, so that tell me there's a poor connection there. So I'm now going to unbolt that and clean that up. Well, I've got to be a little bit careful because I haven't disconnected the battery, so that is 12 volt live. So I'll undo it, but I don't want to touch anything else. You're better off undoing the battery first, because if I hit anything with this spanner, that's going to spark like hell. But I'm feeling brave today. Well, I am an electrician, multi-skill engineer by trade, so I ain't too worried about 12 volts, I've got to admit. So I'll just take that off. Drop that out of the way, and if you look, that nut's all a bit grotty and horrible. So I'm now going to get a file out of a bag or some emery cloth and clean these up. Well, luckily I've got the trusty file, so all I'll do on the nut, give it a clean. Do both sides. Just looking loads better. And on the spring washer as well. Don't get me wrong, it ain't perfect, but it's a lot better than what it was. And luckily I just found my wire brush in the van, so I'll cut studding, get clean as well. Look a little bit dirty because it's got a bit of grease on the brush. So all these terminals I smeared with a little bit of Vaseline. So that should be cleaned up enough what we want. While we're there, that's the 12 volt terminal. We'll give that a clean as well. A bit of rust on it. If you look underneath it, these are just galvanised coated copper terminals. It's not spotless, but it's good enough. So what I'll do is now put this back together. Careful not to touch anything, because it is still got 12 volts on it. Just nick that up. Don't you go too mad. And now we can go back to testing it again. I'm just doing step by step stages. So now, go back to here, put it on there, 12.82 volts. So what we've done, we've cleaned the crimp and the terminal, so now we're getting perfect voltage between them both. Just go right on the end, 12.82, that test, because obviously that's the terminal of the starter, the solenoid. Then it's going through the bolts and to that terminal, so we know that terminal is now good. 12.82. Now I want to test resistance for the rest of the terminals. So what I want to do is take that 12 volt back off again. Now we cleaned that, we proved that's okay. So now I'm going to, obviously that switch isn't made yet because I'm not turning it over. Well, the second stage of testing is testing the continuity from the second terminal on the solenoid to the starter motor coils, and the starter motor coils to the earth or ground. Well, obviously you've got the clip still on there, so I'll put this on resistance. We can test the whole lot in one go. If I press on there, oh, so it's a little bit dirty. I got down to about 5 ohms. Well, that's good. 5 ohms is good because basically that's 5 ohms resistance for the terminals and the coil. So we know the coil's good. If not, that'd be open circuit if the coil was blown a lot of the time, or the coil was high resistance. So the coil in the starter is low resistance and the terminals are low resistance. But I am getting, see, that's got a little bit high now and then. Well, because I'm here doing it, I'm going to undo them 2 terminals and clean them up. Because this fault isn't here all the time, that's intermittent, so it's only on board line. So if I clean them, that's going to help matters. Well, I just loosened the terminals off, and I'll be doing the last little bit with my fingers. So when we tested that, a couple of times that tested good. Another time that tested a bit iffy. So it's a little bit intermittent. You see, they're a bit dirty and grotty. What I want to do, get the trusty file out, give it a clean up. What a lovely shiny copper. That loads better, doesn't it? That one looks pretty good already. Look at that. Spotless. Giving a bit of a clean around that town with a wire brush. And also the other one. There's a little bit of grease on that terminal, on that brush, so I'll just give it a quick wipe over as well. So now I can put that back on. So that's all clean. All on there. All the nuts and bolts look pretty clean underneath. I'm quite surprised. This must have been off before I bought the tractor. Someone's cleaned it up the last few years. As we want to test. As we want to test with that end of that nut, I'll give that a clean as well. Because this is an intermittent fault, you just got to look at resistances. Obviously, that's cutting the 12 volt in and out, isn't it? Like high resistance. can see when we tested then, 1 minute that tested lovely, and next minute that tested poor. I don't want to go too mad on these terminals because they're only that's a bit huge and only brass studs. I'm only just going to nip them. Some brass, some are copper, a bit of a mix and match. So now you can test again. Back to resistance. Let's go on known earth. 4.2. So then we go back to here. See that 4.3 ohms, 4.2 ohms, and we know the meter leads are 3. So we need 1.2 ohms, and we're testing from that terminal on the solenoid through that terminal link, through there, through the coils, and to earth. So we know now all that side of the starter, all is good and test clear. Well, so far we've tested the terminals, tested the link, tested the coil down to earth. We know now with the cleaning that's all good. The only thing we haven't tested is the resistance of the switch. There's a couple more tests we've got to do first. They're both the coils, so we've got to test whether them coils are open circuit or not. So you put your meter on there, 3 ohms, meter on there, 13 ohms. So both them coils are closed and we ain't got a problem with them. Well, after testing, I've virtually tested everything through. The only thing I ain't tested is across that switch. So what I'm now going to do, I'm now going to put my multimeter on here and keep turning over the switch and see what it do. So I've now got it on the switch wire, monitoring it. That's working every time. I've done it about 14, 18 times now. So in that. Well, I just took the cables off and I'm just going to unbolt the showed my ratchet spanners, that's for a cert. Just going to unbolt this and have a look inside. Well, I got the solenoid out and that's now obvious. I'm trying to test across the contacts and it's giving me loads of spurious resistance readings. So basically them contacts inside there are worn. So I have got problems with the starter. That's these contacts. I'm trying to read them by pushing it in manually and they're all over the show. So I'm going to have to take that apart, either clean the contacts up or get a new solenoid. Well, I'll need the trusty soldering iron to take that apart. So I'll just put a bag over the starter, another bag over the positive cable. And now I'm going to go in and see if I can get that apart. Well, I've just got the solenoid home and I'm about to strip it down. This is 2 screws and a couple of nuts, look like a couple of solder points. So I'm now going to just give it a go at undoing it and see if I can get it apart. Well, I've just unsoldered the cables for the coils, these two, and lifted the cap off, and you can see they go carbonised up and eating away them contacts are. You can see I'm surprised it even started at all in it. Well, I'm going to see if I can clean these up. If not, I'll have to buy a new solenoid, but they do look pretty grotty, don't they? So obviously that was the fault of the starter. Well, I'll just put a file on the top contacts and then that can't too bad. There's a little bit of divot in them, but ain't too bad. But if you look at the centrepiece with the switch, that's worn very thin near the edges. I ain't going to be able to repair that, that's gone. So I'm going to have to order a new solenoid. But then again, that wasn't all bad. I can make this video and show people how to diagnose faults and test all the starter motor out. So in case there's a fault, not the fault with the starter, there's a fault with the cabling. So hope you enjoyed it. I'll catch you later. Bye.